Well, all right. We survived permutations. Uh, we got a formula. You got to be careful about formulas. You got to make it work for you. We've only done it for a day, but you got to know that you have this tool. This tool will give you the number of arrangements of R objects picked from N objects. And the idea of arrangements is that you're counting the different orders. So people say order matters. What they're saying is you count different orders separately. So what can we do to this to mess around with? That is the question of the day. So, because I was bored, I wanted to see all the different permutations that you could make with. Let's just get rid of this thing. Oh, there we go. So there it is. Those are all the permutations of the letters A, B, C, D, E. If I choose three of them. That's cool. If you pay attention, you notice that. So A, B, C here, these are the 6 different variations of just those 3 letters. All right, so that's why we count and get so many permutations, because we have one little group of 3 letters, but we can arrange them in 3 times 2 times 1, or 3 factorial, or 6 different ways. Very cool, very cool. All right, so the idea of combinations is different than permutations. Combination relaxes a little bit. It's like, hey, how many groups can we get together instead of how many arrangements? So the combination is a selection of objects without regard to order or arrangement. So it is the exact same idea of pulling things from there, but all we're going to do is take the number of permutations. So we're going to first get our number of permutations, and then we're going to divide out how many ways we can arrange those R objects. So I go back to that same picture, and these 6, I actually just want to count as 1 now. So what we're really looking for is how many ways can I pick the 3 letters, and so that they're all the groupings are a little different. You will notice there are 10 different ways to do that. Okay, all these are the different. If you look at them, none of those 3 are the exact same as the other set. So that's the difference between combinations and permutations. So what do we have to do? We have to first calculate how many permutations, and then just divide that by how many ways did I arrange those 3 letters. Well, remember, it's 3 times 2 times 1, or 3 factorial, the number of elements. So I hope that if you feel good about that equation that we had before, right here is the permutations. Right there's the permutations, and we're taking that value and we're dividing out how many different ways we can arrange those 3 letters. So combinations are not that different than permutations. There's just a lot less of them. So think about that. Notation wise, most American textbooks use that. I've seen this more in like English from the UK. We will specifically all try to use this notation. N choose R is how they kind of say that, and then we have a formula. All right, so how do we evaluate this? Well, if we see that notation, that is saying take 3 factorial over 3 minus 2 factorial, which boils down to 3 factorial over 1 factorial, 2 factorial. Now I want you to notice something. The 2 at the bottom will always add up to the same number at the top. Now, of course, we can look at that formula and say you have n minus r and r. If you add them up, you just get n. But that's something to be, do things quickly. So if you see this, you know it's 3, 2, and what's ever left, 1. So you should be able to do that fast. So calculator. Does it work on a calculator? Absolutely. If I want to tell it to do this, I need to go start with my first number, which is 3. Then I go to math. Math, there's tons of stuff. There's derivatives. There's absolute. Oh, I part. I wonder if we could have done all that complex. Yes, we could do all that complex. We'll do that later. You got to kind of, oh, conjugate. I wonder, real. Oh, all right. PRB is probability. So this is counting. We do a lot of counting for this. Go to NCR. And so it's the 3 is the N, and we need the 2. So if we hit enter, we get 3. And sure enough, 3 factorial divided by 2 factorial is just 3. That makes a lot of sense. If we do 5, math, I go backwards 1, and that just saves me a couple steps. I could type in the number 3 there. 5, choose 3. If we had 5 letters and we want to choose 3, I believe we got 10. And we did. All right. So that is there for your taking. Please use the calculator as much as you want. So the calculator here is, if you plug this in, you would get 4, you would get 7, and you would get 10. If you start putting this in English, if I have 4 objects, how many ways can I choose exactly 1? Well, there's 4 objects. Pull one at a time. Yep, so that makes sense. But maybe can we use this combinatorics, this kind of algebra, a lot of factorials, to prove that no matter what I have for n, will I always get n? And the answer is yes. So we start out with the notation. We plug in our values, so the n minus 1 factorial, 1 factorial. Remember we did this in the very first thing yesterday, is if we can rewrite that as n times n minus 1 factorial. That's going to cancel on the bottom and we just get n. So there we go, we've proved it. Alright, so sometimes, whoa, we just got out of a chapter of polynomials. Is that really a polynomial? Is that a way to write a polynomial? Well, it is. If we plug it in, we put the top, n factorial, we subtract the 2, and then whatever that thing is, in this case n minus 3 factorial. Oh, that is just funny. N minus n, of course, the negative becomes 3 factorial. We can rewrite this as n minus 1, n minus 2, all the way down to n minus 3 factorial. That's going to cancel that. 3 factorial is 6, so we get 1 6, n minus 1, n minus 2. We could multiply that out and get a third degree polynomial. Not interested. All right. These are the type of problems you're going to run into tonight. Let's not give away too much. Physics exam, there's 7 questions. Mr. Sayers says you've got to do 1 and 2, so you really need to choose 3 of the remaining questions. But how many are remaining? There's only 5 remaining. So you're asked, really, how many ways can I choose 3 out of the 5? 3 out of the 5. So those land right in the wheelhouse of combinatorics, and there's got to be something I'm doing. So 5 choose 3, 5 over 3, 5 over 5 minus 3. You know, this is kind of what I would like to see, you know, directly. You don't have to write out that. And then, of course, your calculator tells you 10. You're going to see a lot over and over. So, all right. You might as well memorize a few of them. I did this problem. I did half of it for your homework just to kind of get you started. Well, we got 12 and 5. Part A here is pretty self-explanatory. How many ways can you choose 5 from 12? Okay, so that's just going to be 12 choose 5. That's going to be some number. I don't know what it is. I'm sure I could plug it in the calculator and get it. It's surprisingly large. It's pretty cool. So this, I just you know, it's what do they mean? Well, out of those 12, there is a captain and a vice captain. That's part of the 12. So how many ways can we choose a team where they're picked? So that just changes the numbers a little bit. So how many more do we need? 3. And how many are left? 10. So we're at 10 choose 3 there. 10 choose 3. And finally, what if exactly one of the captains? So this is like now we're thinking about the cases. So we have one is chosen. And why are there only 10 left? Why isn't there 11 left? Well, if we pick like the captain, then we can't pick out of a group that has the vice captain in it. So now we're down to 10. We need 4 more people. All right. Now, what is this? Well, the 2 choose 1 is kind of counting, well, is it going to be the captain or the vice captain? Some people will just say there's 10 choose 4, and that gives you a number, and then we'll multiply that by 2 because one will be the captain, one will be the vice captain. It's a really good idea to start seeing everything in the combinatorics. All right, getting into it a little bit more. So we have a tennis, table tennis, which we used to have one at Pooter. Some people talked me into it for their CAS. It was pretty awesome though, but yeah, they were pretty lazy. All right, the Committee of Table Tennis Club consists of 3 people chosen from 6 males and 8 females. How many different? Well, there are 14 people, if it doesn't matter, and we're just doing 14 choose 3. Boom, big number. I don't know what it is. How many of the different possible committees if there are exactly 3 males? Okay, so now we have to think about, well, we got to pull 3 from the 6 and 0 from the 8. I think it's important to say the 0 from the 8 because that keeps you kind of consistent. So I would love to see, yep, I'm going to count how many ways I can pull 3 from those 6 and 0 from the 8. We're going to get something. 2 males and 1 female then. So 2 males and 1 female. These are being multiplied because for every way you can choose 2 males, there are that many ways to choose 1 female from 8. So make sure that you are multiplying. That should be enough for you. All right, now we start to get into a little bit more interesting. 12 distinct points on a circle. We draw a line between each pair of points, and I think that's pretty key right there. How many lines total are there? Well, there's 12 points. We're counting the lines. How many points does a line need? 2. So 12 choose 2 is counting how many. Now, if you had point A and point B, if you wanted to count that line, you're counting AB. But the beautiful thing about combinations is you're not counting BA then. Okay, you've counted one grouping of those 2. All right, which pass through B? That just means B is one of the 2 points. So how many points are left? We get 11. We have to figure out how many of them you are. If you find yourself drawing a picture, then you've gone too far. All right, last problem. I worked on this. This was fun. And I needed just a little bit of a picture, and then boom. So line A includes 10 points. Line B has 7 points. The points on the line A are all joined. And so can you just see all the lines? Just all over the place. You know, this one is just everyone. So how many points of intersection? Whoa, that's kind of amazing. So check this out. If I pick any 2 points on A and any 2 points of B, I can draw a bunch of lines. I can draw this one to this one. I can draw this one to this one. I can draw it to that one. I can do all those. But out of those 2 pairs, there's only one scenario where it's going to create a point of intersection. And I didn't believe it, so I drew it and just, wow, that is amazing. So really we have to count how many ways we can choose 2 points off of this line and how many ways we can choose 2 points off of this line. They have to be different. So, you know, this is A and B. If I choose A and B, I don't want to count B and A. Oh, combinations. So the bottom line here is I'm going to do 10 choose 2 times 7 choose 2. That should give me all the ways I can count, get a pair here and get a pair here, if I believe that that's the scenario that coughs up one point of intersection. If you don't believe it, you got to just draw a picture, see if there's another way to do it. It's cool. Oh, so if you like that problem, what? All I can tell you, and this is number 26, I don't know if I even assigned it, you still need 4 points. You still need 4 points. So how do you decide where those 4 points come from? Could they all come from this side? No, those don't intersect. The play doesn't work that way. But if I pick 2 from this side and 2 from this side, that would certainly create 1 point of intersection. If I pick 2 from this side and 2 from this side, that would certainly give me all the points of intersection. If I picked 2 from this side and 2 from this side, I would get a bunch more. So maybe we need to find these separately and then add them. Like you're thinking, Mr. Sayers, there's another color somewhere. Let's go green. Could I pick 1 here, 1 here, and 2 here? Would that give me 4 points that there's only 1 point of intersection? Good luck. If you get everything done and you want to try that one, it's 26. It's interesting, and I've definitely given you enough to get started. So if you want, feel free to finish that sucker up. Under 20 minutes. Thank you very much.